Hi, welcome to a lesson about primes. So what is a prime number anyways? A prime number is kind of a building block. By multiplying primes together, we can get all the different positive whole numbers, past 1 at least. So a prime number is a number with exactly 2 distinct positive integers as factors. The number 1 only has one factor that's a positive whole number itself. So we call 1 a unit. And any number that has more than 2 factors we call composite. So for example, 12 is divisible by 1 and 12, but it also has factors 2, 3, 4, and 6. So many more factors than 2. You could even take a number like 2. It has factors 1 and 4, but you can also write 4 as 2 times 2. So it has 3 different factors, 1, 2, and 4. Numbers that are not primes that have more than 2 different positive integers as factors are called composite, because composites are made by multiplying primes. Just like in building materials, composites are things built from other things. So as an example, 2 is prime because the only way you can factor it is 1 and 2 or 2 and 1. It only has 2 different factors, itself and 1. 15 is composite, not prime, because 15 has factors 1, 3, 5, and 15. Definitely not 2. And so on the next slide, I'm going to give you the first 5 prime numbers and also the first 5 composite numbers. You might want to stop for a few seconds and see if you can name the first 5 primes and the first 5 composites. So the first 5 prime numbers are 2, 3, 5, 7, and 11. And it's easy to start just saying odd numbers, but 9 is not a prime because you can write it as 3 times 3 instead of just 1 times itself. And remember that 1's called a unit. It's not a prime. It's not a composite. The first 5 composite numbers are 4, 6, 8, 9, and 10, because if each of those can be factored in a non-trivial way that doesn't use just 1 in itself. 2 times 2 is 4, 2 times 3 is 6, 4 times 2 is 8, and 3 times 3 is 9. So the fundamental theorem of arithmetic underlies all of our facts about multiplication of natural numbers. And it says that if I take a natural number past 1, it's either a prime itself, or you can write it as a product of primes in exactly one way if you write the primes from least to greatest. And for a prime like 5, we just write it as 5 and sort of think of that as being a really extra simple product. So here is an example. I've taken the composite number 24. I can write it as 2 times 2 times 2 times 3. Or I can use exponents so I don't have to write so much. Since I'm using 3 copies of 2, I put a 2 with a little 3. My exponent says I'm multiplying 3 copies of 2 together and then times the 3. And you may remember factor trees from elementary school. And a factor tree is a way to factor any natural number into a product of primes past 1. So I've taken the number 2100 and I'm going to make a factor tree for it. And I'm going to describe it in words in the next slide, but maybe I'll just talk through it here so you can see the picture. So 2100, I factor it any way I can think of that doesn't just use 2101. So here I've decided to use 21 and 100. Now I take each of those numbers. If the number's prime, I'm going to circle it, or here I've used red because circling was way too hard. So 21 is not prime, so I'm going to factor him. 21 is 3 times 7. 3 times 7, those are both primes, 3 and 7, so I would circle them on my paper, or here I'll write them in red. And then I do the same thing with the 100. I could factor him. I could do 25 times 4. I could do 2 times 50, whatever way you like. I split it into 10 times 10. And then the 10 I can write as a product of 2 times 5 and both of those 2 and the 5 are primes, so I made them red, or on my paper I would circle them. I think of those as being the fruit of my factor trees. In elementary school, you might have done these the opposite way, where you put your primes at the bottom. That's okay, but I like my tree to look like a tree. I don't want to make it look like a root system. I think they should have called them factor roots if they wanted to make them go down. My trees grow up. The downside of that is that I have to leave enough room for my factor tree, but it generally works. So look at those red numbers, and those are what we're going to use to factor 2100 as a product of prime guaranteed by that fundamental theorem of arithmetic. So now I've described on this slide what I did. If you're happy with that, you can go to the next slide. Otherwise, you can go ahead and read it again. So my primes are those red, maybe circled fruits. I put them in order from least to greatest. And I had 2 2s, a 3, 5 5s, and a 7. And so I write those in that order. I have now factored 2100 into primes. It would look nicer if I used exponents, right? I have 2 copies of 2. I have 2 copies of 5. So I'm going to use a 2 squared instead of 2 times 2, and a 5 squared instead of 5 times 5.